Kids, welcome to your first math presentation with Mr. Adam. So a couple of disclaimers before I get started talking about the Pythagorean theorem is that the great thing is that I teach math like a student. I am not by nature a mathematician. It was in fact the Montessori materials that helped me get familiar with math and helped me fall in love with math. One of those materials that I'm going to talk about today is from the geometry cabinet on the Pythagorean theorem. So that's my disclaimer. I am not Miss Carol. I'm not even Mr. Matt. When it comes to math, I am just here doing what I can do to help you guys understand the way that I do. So this presentation should be a lot of fun. This is primarily geared toward 5th and 6th graders, but 3rd graders and 4th graders, I encourage you to listen, and 7th and 8th graders, I encourage you to review. There's going to be a little history, a lot of math, and some drawing as well. All right, so here we go. This is a visual representation of the Pythagorean theorem. If you look at the blue side here, we're going to call that A. Oh, whoops, there we go. So the side of the, don't do that. The side of the triangle here, fix this, see? Already making mistakes, but that's okay. So this side of the triangle we're going to call A. We're going to call the bottom side B, and we're going to call the long side, which is called the hypotenuse of the triangle, we're going to call that C. Okay? So let me draw that for you. So we're going to call that A, B, and C, and I'm sorry that mine is reversed from the other side, but you notice that C is still the long one across from the right angle. That symbol that I drew on there is the symbol of a right angle, and the Pythagorean theorem only works with right angles. So what is the Pythagorean theorem? It's the idea that if we take side A and we square it, and we take side B and we square it, if we add those together, they will equal C squared, and then we could take the square root of C squared to get C. So what does it mean to square something? Well, to square something means to multiply a number by itself. Let me show you here on my other piece of paper. If I have 2 squared, and that's the exponent 2, that is the same as 2 times 2, and I apologize if they look like z's. So 2 squared is the same as 2 times 2, and that of course is, that's right, you guessed it, 4. The formula that you see here, a squared plus b squared equals c squared, is the Pythagorean theorem. So let's back up a little bit and let's talk a little bit about the history of the Pythagorean theorem. What you probably don't know is that the Pythagorean theorem has been known since ancient times. Pythagoras wasn't the first one to discover it. He's an ancient pre-Socratic philosopher, but he's the one whose name is attached to it. The first known one that we have comes from around 1800 BCE. As far as Pythagoras is concerned, he lived from 580 to 500 BCE. He was a pre-Socratic philosopher. Typically in the history of philosophy, it's all about what happened before Socrates and then what happens after Socrates. He's that important. Pythagoras was kind of a strange guy. He had a mystical cult based on numbers. Another interesting fact you should know, and this is a little bit of a history lesson, is that he thought the Earth was a sphere. And a lot of people have this misconception that the ancient world and pre-moderns, they thought that the world was flat. Well, that is, nothing could be further from the truth. The real concern, the real misconception that they had is that they believed that the Earth was at the center of their universe and that everything sort of revolved around the Earth. So the idea of celestial spheres rotating around the Earth, or different layers of spheres, that is an ancient idea that goes back to the Babylonians, Egyptians, ancient Mesopotamians, the Greeks, etc., etc. The real discovery is realizing that no, the sun is actually at the center of our galaxy and we are rotating around it. So interesting fun fact about Pythagoras, he thought that the Earth was a sphere. He knew that the world was a sphere. Great for you, Pythagoras. That's excellent. Now, back to the math. So I wrote a squared plus b squared equals c squared. So I'm going to show you on this piece of paper abstractly, and then I'm going to go back and do it here to show you the magic of the Montessori material. Let's go with, let's say A is 3 centimeters and B is 4 centimeters. And we do not know what side C is. There's that question mark. Okay? Well, according to the Pythagorean theorem, I should be able to take my A, which is 3 centimeters, and square it, my B, which is 4 centimeters, and square it, and get C squared. So let's try that. Notice what I did here. 3 squared plus 4 squared will give us c squared. Okay. Well, 3 squared is the same as 3 times 3. And 4 squared is the same as 4 times 4. Now, why did I put them in parentheses? Well, when we do order of operations, we always do parentheses and exponents first, and I'm only putting them in parentheses here just as a little, I guess, signal to you 3rd and 4th graders that that's all it means. 3 squared is just 3 times 3. But we have to do that first, and then we're going to add that to whatever 4 times 4 is. So let's do that now. Well, we know that 3 times 3 is 9. And we know that 4 times 4 is 16, and that actually gives us c squared. C squared in this case is equal to, that's right, you guessed it, 25, but it's going to be centimeters squared. Okay, let me not forget my units. If Miss Carol were here, which she would remind me to make sure I had my units. So 25 centimeters squared. Now, because a lot of you haven't learned how to do square roots, what we need to do is keep it simple now and think, what number multiplied by itself gives us 25? Think about that. What number multiplied by itself gives us 25? Well, if you thought 25, or if you thought 5, you are correct. 5 times 5 is 25. So if we take the square root of c squared, and the square root of 25, we get 5. Do not be alarmed by the symbol that I put there, the square root symbol, for those of you that are unfamiliar. And I apologize, I do have to get better at using my paper. But guess what? It's my first run here doing math. That's what I was going for. Much better. Okay, so, or C, oh, sorry. C equals 5. And a lot of you out there are like, great, you figured out that the length was 5. How can I trust you? Well, that's exactly right. If C is in fact 5 centimeters, then we're good, right? Well, we're going to have to show you with the work why this actually, and how this actually looks, and why this is actually true. And I will give you another example when I draw it with the centimeters, and then we'll go from there. Okay, so here goes with the material. You see at the material that I have a side length of 3. 1, 2, 3. Okay? With a little closer look here. A side length of 1, 2, 3. Now, why do I have an entire square there? Well, that's because when you square something, you make a square out of the units. And that's exactly what we're doing. C squared is literally all of these together. So if C is 3, 3 times itself is 1, 2, 3, 4, 5, 6, 7, 8, 9. So c squared is 9. Let's look at, or I'm sorry, a squared, not c squared, my bad, a squared. So this is a squared, 1, 2, 3, 4, 5, 6, 7, 8, 9. B squared is going to be 4 times 4. Let's count those. I think you guys are going to count them for me. I think you know what we're going to get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Awesome. Okay. Well, that's great. We have 9, we have 16, and then we're going to count the ones over here. This is c squared because the length of c is 5. 1, 2, 3, 4, 5. That's its length, but we're squaring it. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, well, let's show you how that actually works. So I'm going to take out the reds and I'm going to replace them with the yellows and the blues to show you that, in fact, this is the Pythagorean theorem at work. Taking out my reds. And replace them with my yellows and my blues. Kids, when we do eventually come back to school, I highly recommend you just take this workout and try it and see how squares work. The Pythagorean theorem is a powerful tool. One student was actually working on a problem that we had to use the Pythagorean theorem to find the length or the height of a tree. And it was all about not only similar shapes, but also using the Pythagorean theorem. So, I've got them added up here, but I'm going to have to use my red to fill in the blanks at the bottom here, or things are going to fall down. And the reason this works, kids, the great reveal, is that I'm using a unit that is about a centimeter in length, maybe a little bit more than that. In fact, I got a ruler here. Now, each of these is a little bit more than a centimeter, about a centimeter and a half, but if each one is the same, the math is going to check out, because that's how this works. And by the way, this 3, A being 3, B being 4, and C being 5 is called a Pythagorean triple. It's in fact the smallest of the whole number or integer Pythagorean triples. So there you have it. You can see how the initial A's and B's squared formed a square that was equal to what was originally the reds, which was c squared. And that is how this work works. We are trying to teach you that a squared plus b squared equals c squared. It is a mathematical or geometric rule that works with right triangles. So, and of course I've replaced the blues and the reds, the A's and the B's, or the yellows and the blues with the red here. So let's talk a little bit more about the Pythagorean theorem and how what you can do as a follow-up exercise and how this works. Well, first of all, let me give you a few more Pythagorean triples, because the more of these that you know, the better off you're going to be when it comes to word problems that may show up. You might be like, oh wait, this is a 3, 4, 5 triangle, because somebody gives you a 6, 8, 10 triangle. Well, 6, 8, 10 is just a multiple of 3, 4, 5. And so you're going to know that a 6, 8, 10 triangle also follows the rules of the Pythagorean theorem. So 3, 4, 5 is the obvious first one. The next one is a 5, 12, 13, followed by 8, 15, 17, 7, 24, 25, and 20, 21, 29. So those are Pythagorean triples. Again, 3, 4, 5. Let me write this down for you. So these are some of your basic Pythagorean triples. I highly recommend that you memorize them. Okay, very important to do that. One thing I want to do now is I want to show you what you can do as a follow-up exercise here that can really help you with your learning your Pythagorean theorem. So for you 5th and 6th graders who this is primarily geared toward, this will be for you. 3rd and 4th graders, I would love it if you guys could just draw these triangles, and I would actually measure them out and color them. And for you 7th and 8th graders, this is review. I would love it if you guys could, prove that you can memorize maybe 3 or 4. Actually, no, memorize this. Middle schoolers, memorize these Pythagorean triples, and maybe a few more. So here we go. Let me show you how I can create a Pythagorean triple with my pencil and my paper. So what you're going to need is a ruler, straight edge, and what I'm going to do is I'm going to make one that is based on inches, and I'm going to start with 3 inches for my side A. And 4 inches for side B. And I'm going to just put my ruler on here and draw a line. And hopefully I'm close. Hopefully my right angle is close here. Sorry, I forgot to draw that. That's the symbol for a right angle. Oh my God, it's close to perfect. Oh. This is amazing. Mathematical stuff that actually works. I love it. I'm going to hold this up. Look at that. Ugh. I'm on 5, folks. I'm on 5. That worked. Oh my Lord, that worked. I literally just drew 3, 4, and the 5. I didn't even have to measure it. It would have been true. You know why? Because it's a mathematical law. It's geometry. It's amazing. This is why we study people like Plato. He was really into this stuff too. Pythagoras, all these Greek philosophers, all these Babylonian, Mesopotamian, ancient Indian, Chinese philosophers, all of these people, they were so into these geometric laws. This is amazing. So I drew that here. Now, what I didn't leave room for, which I should have, is actually building the squares off to the side. So 5th and 6th graders, when you do this, I would start with the 3, 4, 5, but I would do it on, I would probably do it with centimeters so you don't run into the same problem I just ran into. So that you can actually draw the squares off to the side. And they're going to have to be square centimeters. So again, to review, how did I know that this was going to be 5 inches without even having to draw the line, but then proving myself right? How did I know? Because of the Pythagorean theorem. Let me write it down again. There it is, one more time. A squared plus B squared equals C squared. We did this already. We know that 9 inches plus 16 inches equals 25 inches, okay, squared. And that's pretty much how we did it. So that is amazing. Math and geometry is so cool. I learned something new every day. I had no idea that was going to work out the way it did, but I should have trusted, the math. And that's exactly why geometry is so exciting. I love the history part of this. I love the fact that the Pythagorean theorem has been around so much longer. So for your follow-up activities, I would love for each of you to draw something like a 3, 4, 5, or what were the other ones? 5, 12, 13, 8, 15, 17, 7, 24, 25, 20, 21, 29. Have fun. You can make this as big or as small as you'd like. But it is going to work. I highly recommend you stick with the Pythagorean triples, though, because otherwise you're going to end up with decimals. And for those of you who haven't studied those, that might cause some problems. Let's keep it simple, and let's keep focused on the actual formula itself. A squared plus b squared equals c squared. I apologize for not giving you all of the nomenclature that you may necessarily need to have. I will remind you that this side here, this is called the hypotenuse. That is always going to be c squared. It's always the one across from the right angle. So whatever the one is across from the right angle, that is your hypotenuse. Okay? So that's how that's going to work. If you have Lego bricks at home, I highly recommend you do this with Lego bricks. Use the square ones. It will work. Okay? It's going to work. The geometry checks out. And now, for a bit of DuPage history, I'm going to take the computer and I'm going to show you guys where the Pythagorean theorem has been in front of us the entire time, and we may not have noticed it. Hold on. Taking a tour of the classroom. I think some of you may see it. That's right. Oh my Lord, kids. Take a look. Right here we have a 3, 4, 5 triangle on the quilt. Okay, if I counted the red squares, there would be 9 of them. If you get a close-up, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. When I go to the reds, okay, you can see or the yellows, you can see that a little bit easier. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so we've got 9, 16. Let's count the orange ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Little history behind this quilt, kids. I know you've seen it. Now you understand the geometry behind it. This was the second quilt that my class ever made back at the old location. Back in 2010, students and I actually, we were doing quilts for auctions, and we decided to make a math quilt. This was for Miss Carol and for the classroom. A parent bought this and then donated it back. And kids, you may